Previously, we've seen that we can vary charge 1's value while keeping charge 2's value constant, and that varies the magnitude of force between the two charges. Or we can vary charge 2's value while keeping charge 1 constant, and that also varies the force between the two charges. Further, we saw that the magnitude of the force between the two charges is directly proportional to Q1, and the magnitude of the force between the two charges is also directly proportional to Q2. So now we want to bring both of those pieces of data together so that we can say one thing about the effect of charge on force. So what do you think our focus question is going to be if we're going to pool the data from the previous two investigations together? How does the product of the charges affect the force between the two charges? In other words, how does Q1 multiplied by Q2 affect what force exists between the charges? The magnitude of the force, of course. So what must be kept controlled between all of these treatments? The distance between the two charges. And we're going to keep that at 4 meters. So if that is now our question, how does the product of the charges affect the force between the two charges? What should the heading of our table be? And what should the heading of each column in the table be? Pause until you've done that yourself. Table showing the relationship between the product of the charges, Q1 times Q2, and the force between the two charges. What are the headings going to be? Q1 times Q2 is our independent variable, and its unit is Coulomb squared, because Q1's unit is coulombs, and Q2's unit is also coulombs, so coulombs times coulombs equals Coulomb squared. Force between the two charges is our dependent variable, unit newtons. But now we don't automatically know the product of the two charges. We need a space to record what we do know, so we can then calculate the product. So we add 2 columns to the left, Q1 in coulombs, Q2 in coulombs. And from that, of course, we can multiply the two to get our real independent variable for this investigation, Q1 times Q2. So we have already collected the data for this. If necessary, go back to those investigations where we had these simulations. First of all, remember, we controlled Q2 at 200 times 10 to the power minus 6 coulombs, and we increased Q1's value from 6 times 10 to the power minus 6 through various readings up till a maximum of 50 times 10 to the power minus 6 coulombs. And as we did that, the force between the two charges increased in magnitude from 0.7 newtons up through various values to a maximum of 6.1 newtons. And that's the data put into the table from our first investigation. As you can see, Q2 was controlled at 200 times 10 to the power minus 6 coulombs, but Q1's value was increased from 6 times 10 to the power minus 6 all the way to 50 times 10 to the power minus 6. And here are the corresponding force values from 0.7 newtons all the way up to 6.1 newtons. And indeed, we did find that the force between the two particles was directly proportional to the magnitude of Q1's charge when Q2 was controlled. Then we did another investigation where we controlled Q1's value at 50 times 10 to the power minus 6 coulombs, but we varied Q2's value from the lowest reading of 200 times 10 to the power minus 6 coulombs, where the force was 6.1 newtons, up through various values until we reached the maximum of 600 times 10 to the power minus 6 coulombs for Q2, and that was associated with the highest force that we read, 18.3 newtons. And there we put that data into our table as well. You can see for this section we controlled Q1's value at 50 times 10 to the power minus 6 newtons. We increased Q2's value from 200 times 10 to the power minus 6 all the way to 600 times 10 to the power minus 6. And indeed the force between the two charges did increase from 6.1 up till 18.3. And there we found that the force was also directly proportional, in this case to Q2's value, since Q1 was controlled. Now we are actually trying to find out whether, when you multiply Q1 by Q2, and therefore you get a new variable, which is the product of the two charges, Q1 times Q2, is that new variable proportional to the force between the two charges? So the first step in checking that is we need to multiply Q1 by Q2. 6 times 10 to the power minus 6 multiplied by 200 times 10 to the power minus 6 equals. You complete the table, do all the calculations yourself, pause the movie until you finish that. And this is the data that you should have got. So what do we see about this data? Well, indeed, we do see that as Q1 times Q2 increases, the force between the two charges also increases. But is this relationship direct proportion? When we plot this data on the graph, we again find a straight line. Extend the line to the 0 point and it will cut 0, 0. The origin. So this certainly does seem as if we have direct proportion. By the way, you should actually plot the data yourself from the table. Make your own graph to check this, whether I've done this correctly, and to practice drawing graphs. But at the least, you need to give me the heading of the graph as well as the labels for the x and the y axes. Graph showing the effect of product of charge on the force between the charges. Product of charge, Q1 times Q2, measured in Coulomb squared, is our independent variable on the x-axis. Force between the charges, measured in newtons, is our dependent variable on the y-axis. So what is our conclusion? The force between two charges is directly proportional to the product of the charges, Q1 times Q2. We can write this mathematically using the mathematical symbol for proportion. Force is directly proportional to the product of Q1 and Q2.